Okay, so today's lesson will be about space exploration. So we'll dive into all the different things humans have done to reach space and to learn more about space. And so we'll start with an introduction, the space exploration. So while astronomy dates back to many millennia ago, space exploration is actually pretty recent. If you have a question, you can raise your hand. Space exploration was pretty recent, and in fact, the first man-made object in space was only in 1949, which is relatively recent compared to the history of the human race and history of astronomy and constellations and this like such that. So we'll go from 1949, and then we'll slowly work our way towards the present and look at all the human accomplishments in the field of space and astronomy.
So before 1949, there was no space exploration at all?
1949 was the first time that humans reached space, like a man-made object reached space.
How many years ago is that?
Like about 80, like 73. So we'll move on to Sputnik. A lot of you might have heard of Sputnik, but Sputnik was the first satellite, the first man-made object to orbit the Earth. And this was in 1957. It looked kind of like a little bit bigger than a basketball with antenna poking out of it, and was very famous because it was actually it was pretty hard at the time to create an object that orbits, which means to go all the way around Earth. And it did so several times, broadcasting radio signals as it went so that humans could track it, and was a big accomplishment for the Soviet Union who launched it. The Explorer 1 was launched actually a couple months later and was more sophisticated and was able to take measurements of different like layers in the atmosphere and different rays that come from the sun, and was the second man-made object to reach space, or the first US man-made object to reach space. There was a Soviet one, there was Sputnik 1, and there were also a few others Soviet missions to go to space in this time period. So we'll go to this into the space race, and the space race dominated much of the space accomplishments during this time period because it spanned all the way from 1950, 1949, all the way to 1990 almost. And the space race was a time where there was competition between the Soviet Union and the United States to achieve a superior space flight, basically. So to create more advanced rockets and to reach more far distant places. And as you can see in this timeline, when the first human went to space, 1961, the first spacecraft on the moon, 1959, that was also, both those were done by the Soviet Union. The first spacewalk in 1965 was also done by the Soviet Union. And then the US was able to land the first man on the moon in 1969. And then the first spacecraft on Mars was also done by the Soviet Union in 1971. And these are just a couple of the firsts that happened during this time of the space race, when there was fierce competition between the Soviet Union and the US to reach space and to learn more about it.
Okay, sir, please. You said the first man to move to the space also.
The first person to go into space was Yuri Gagarin.
Yuri Gagarin. Can I see the spelling or something?
What? The spelling is right here.
Okay.
Yuri Gagarin. And he actually only went to space for around half an hour and quickly came back down to Earth. Can you please mute if you're not talking? Thank you. So the US followed after Yuri Gagarin and sent Alan Shepard. So please mute. Sent Alan Shepard into space subsequently.
Just a second, he's only in space for half an hour?
Yes, the first person in space, yes.
So he just left the atmosphere, like he left Earth's atmosphere and then returned in half an hour?
Yeah. I think he actually, no, he orbited the Earth once, so it would have been around 90 minutes, so more than an hour.
I have a question.
Yeah.
What does it mean to leave the atmosphere?
It means to leave the Earth, leave the air, leave. The atmosphere is basically air that surrounds us, and to go into space means to leave that air. And there's a border. It's about I think 100 kilometers up. So the
You
first,
mean the border of the earth is 100 kilometers thick?
no, the border from Earth
Away.
to space is 100 kilometers away.
Okay.
So basically, you can go into space fairly quickly.
Yeah, but it's very hard because you need to go against gravity. But the first American to go to space was Alan Shepard, and he did so just direct almost a couple months after Yuri Gagarin. But he only went for 15 minutes. He just followed like a plane, but just went up higher. And then about a year after that, the Soviet Union was able to put someone in space for a day, and that was a big accomplishment. And he was able to orbit the Earth several times. And yeah, before the first man on the moon, Neil Armstrong, there were many missions. One example by the US was the Gemini missions to see how long humans could survive in space and what being in space does to a human, to see if humans could actually spend enough time in space to reach the moon and come back. And Neil Armstrong was part of these Gemini missions before he went to the moon with Buzz Aldrin and Michael Collins. So apart from those human accomplishments, the Voyager 1 and 2 missions were also around this time in 1977. And these are currently the farthest man-made objects from Earth. So we launched them almost more than 50 years ago. And these have been just traveling away from Earth ever since then and have already left the solar system. So there's a border between the solar system and interstellar space, and they have reached interstellar space quite recently, actually, with Voyager 1 reaching it in 2012 and Voyager 2 reaching it in 2018.
So
Yeah.
they left, 1 second, so they left the earth 50 years ago and just now they've reached beyond the Milky Way galaxy?
No, they reached beyond the solar system.
What does that mean?
Our solar system contains our sun and all our planets and the asteroids in the solar system. And the spaceship has passed that border.
Oh, so it's very little actually.
Yeah. Because there's no way to have them travel very fast. In fact, just to get them outside the solar system and to get them, basically the sun's gravity wants to pull everything inward. And in order to get the spaceship not be pulled inward, you need to do something called gravitational assist, which is when you go next to a planet and that planet's gravity makes you faster. It basically pulls on the spaceship and makes you faster and slingshots you away. As you can see in this diagram, the spaceship didn't take a direct line out of the solar system, but rather a spiral path in order to meet the most amount of planets required to keep on slingshotting and becoming faster and faster, so you can actually get outside of the solar system.
I saw that in a movie called Mars once.
Mhm. So Voyager 2 traveled by Jupiter, Saturn, Uranus, and Neptune, while Voyager 1 traveled just by Jupiter and Saturn and then slingshotted out and is actually much faster. And that's why it reached the border much quicker than Voyager 2. And as you can see in this picture below, this is what the Voyager 1 and 2 spacecraft look like. It's very simple, in fact. It has an antenna, a battery it's basically a what's called atomic battery. So it uses radiation to create heat, to
I
create
have a quick
energy.
question.
Yes.
When you say these ships travel by a certain planet, what do you mean? They go
They go
they
next.
use gravitational pull?
Yeah.
Oh, okay.
They just travel next to it.
Please, I have a question. Is
Yeah.
it possible for someone to run in space? Because I thought that someone can run in space.
What did you say? Can you?
I mean,
He's
is it
at-
possible for someone to run in space?
Wait, can you repeat that again?
He's
Sorry.
asking if it's possible to run in space.
No, it's not possible because there's no gravity, so you'll just float. So the Voyager spaceship had an antenna, and it's actually still communicating with Earth to this date. And will actually run out of battery in about 8 years. So by running out of battery, it means it won't have enough power to communicate with Earth anymore, and will just travel by itself for however long, for many, many billions of years. Even after the Earth gets consumed by the sun and the sun explodes, these spacecraft will still be traveling away, which is very interesting to think about. And they may be like the last remnants or the last examples of the human race. So we'll now look at space telescopes. We're going to look more into telescopes in our next lesson, but this also pertains to this lesson about the history of astronomy. And as we build bigger and bigger telescopes on Earth, we realize that the atmosphere actually inhibits a lot of the light, and that means the images are less clear, and it's impossible to see objects that are too far away through the atmosphere, which means we sent telescopes into space, so that's outside of the atmosphere, in order to better see these deep space objects. These include the Hubble and James Webb telescopes, which will be discussed in detail in the next lesson, but also 10 or so other telescopes that are either orbiting Earth or orbiting near Earth and look into space, or sometimes look at the planets or look at the sun even, taking measurements and basically allowing us to learn more about the solar system, astronomy, and just like stars and galaxies in general. The space stations are also a very cool the ISS started towards the 1990s, but there were a few space stations before that, with the Salyut stations in the 1970s. And the Salyut stations, made by the Soviet Union, were the first space stations where astronauts could spend extended periods of time there, like sleeping and eating and doing experiments into what human life was in space. And nowadays, we do those experiments, but we also do many different other experiments about space and vacuums and just seeing how things behave in space. And meaning now there's a permanent crew, or there's always people in the ISS trying to do different experiments and different things to learn more about what it would be like to travel in space, and if humans could travel to space, because that's necessary when we want to reach any other objects like the moon or Mars. Answering the question in chat, can jetpacks be used in space? Yes, jetpacks can be used in space. In fact, when astronauts go on their moonwalks, they have jetpacks, like it's attached to their spacesuits in case they get too far from the space station or lose contact through the tether. And so, yes, jetpacks are the main way astronauts will be moving around in space if they're outside the space station.
Okay, please, does this space station relate with the parking orbit in space or something?
What did you say?
I say, does this space station relate with this parking orbit in space?
Does it orbit? Does it orbit in space?
Yeah, as in parking orbit, as taught to us in class, something like that.
It was, wait, can you repeat that? Sorry, I didn't understand.
I said, does this space station relate with the parking orbit in space?
The packing orbit?
Yeah.
I'm not sure what that is, but
Okay,
space
never
station-
mind.
these space stations orbit around Earth, and in something called the low Earth orbit, which means that are relatively close to the Earth compared to other satellites. Okay, now we'll look at Mars rovers. So outside the Earth, we've sent rovers to many different planets and moons, and one of the most frequent one of the most frequent places that we send these rovers are Mars, because Mars seems like the best place that we could create a human civilization, maybe outside of Earth and maybe the moon, because Mars has a thin atmosphere and it's not too cold or warm. It is a lot colder than Earth, but it could be possible to sustain life in a space station if you build it on Mars. We've also looked at Mars for signs of life, which is another main reason we send all these rovers to Mars. And the most recent one is the Perseverance, about a year ago. But these rovers collect a lot of data, like the temperature, composition of rocks, and weather, and most of that is actually to see if could have been life in Mars or if there still is life. And
I have a question.
yes.
So what's the purpose for finding, why are we doing Mars exploration? Why do we want to find life? Why can't we just be on the Earth?
Because we find the idea of life outside of Earth very interesting, and we are very curious to see what life would be like outside of Earth, how it would survive, and it would be important to know if life could survive out of Earth for us if we ever want to live outside of Earth.
Okay, thank you.
Something interesting about the recent spaceship is that it actually sent a helicopter, like a drone, as you can see in this picture, into Mars. This drone has to spin very fast because of the low atmosphere, but there is some air, there's no oxygen, but there is some carbon dioxide and some trace gases on Mars that allow a helicopter to fly, which is why we sent that there. And it has flown and taken video of it flying, which is very cool. Interesting. So now we'll go to the future space plan. So that's a lot of the stuff we've done in the past, but in the future, we are planning Artemis mission, which is NASA's bringing humans back to the moon. We haven't been to the moon in over 50 years, until ever since the last Apollo mission, I think Apollo 18. And we want to actually go back to the moon now and establish a more permanent base on the moon or in orbit around the moon. And they're already testing rockets. It's called the SLS, Space Launch System, to send astronauts to the moon. And they're doing unmanned tests later this year. In fact, this is scheduled. Can you please mute? If you're not talking? They're sending an unmanned mission this year, and there's plans, although they may get delayed, to send the first manned mission to the moon in 2024, which is in 2 years. And in the future, companies like SpaceX and NASA are trying to also get people to Mars, which requires much bigger rockets. And because of the amount of resources, like food you need to bring, as well as the amount of fuel in order to go to Mars and then come back. But that's something that could potentially happen within this century. Does anyone have any questions about any of that?
I have a question.
Yes.
Please, how possible is it that man can survive in the moon? As in, I don't understand.
Well, people have already gone to the moon, like Neil Armstrong, and have survived on the moon for a day or two.
Don't steal my USB lightning, okay? Just because I keep.
In fact, the later missions survived on the moon for longer and actually had rovers that travel on the moon, which are basically almost like cars, but they're meant for the moon to travel around, collect moon rock. And with these new missions, if you were to build a space station, let's say orbiting the moon or on the moon, man could survive on the moon for extended periods of time. It would be a lot harder than in a space in the ISS or on Earth, though, because supplying it is harder and actually communicating with Earth is harder. Yeah, someone can survive for 7 days on the moon. There have There have been people who've spent years in the ISS. I think a year. Astronauts who spent around 6 months in the ISS. However, there's been Russian astronauts that have spent a lot longer. And so 7 days. In fact, Neil Armstrong was in space for 7 days when he first went to the moon, because it takes around 3 days to get to the moon, spends a day on the moon, and 3 days to get back.
What is the current state of the ISS? Is it the same one as, is it still the original one? And if so, is it still running the same way?
Yeah, it's still the original one. There have been constant additions to it, but it's still the original ISS, yes. Okay, and so I also want to talk about the Future Astronomers YouTube channel, which, in case you haven't, if you missed any previous lessons and you'd like to learn more about the different topics like planets and moons, we've also done galaxies in the universe and also done stars. You can check them out in the Future Astronomers YouTube channel. I'll post the link in chat, but so feel free to, on your own time, go back. This one will be posted there later, but if you want to just have a recap on any of the different lessons that we've gone through, it'll all be compiled on that YouTube channel. And with that, that's all the content I have right now. If there are any questions, feel free to ask. And also feel free to suggest future topics that you're interested in learning about. As our next topic is probably going to be telescopes, but after that, I'm open to any different topics about astronomy that someone that you're interested in learning about or have questions about or are curious about. So feel free to put in the chat or unmute yourself.
So how long does the ISS take to orbit the Earth? Is it 90 minutes or 60 minutes?
It's 90 minutes. to orbit.
Okay. Thank you.
If there's any other questions or any other suggestions for future topics that you're interested about, feel
What
free.
is the future
I have a
of
question.
space exploration?
Wait, what's your question?
I have a question.
Yes.
Oh, how long will someone?
Sorry, you're cutting out. I can't hear you. Sorry. Does anyone have any other questions? Or any suggestions for future topics? Yes, can you repeat that? If no one has any questions, then that's it for this meeting.
So maybe Luca, you can mention about the ISS. I think there's a link, and if you give your email address, then they send you a message every time the station goes over your area.
Mhm. Yeah.
Oh, that's
Yeah, you can.
I have a question.
Yes.
Okay. Please, does taking human to the moon warrant the person to be going around with oxygen or stuff?
Yeah, the people on the moon will need oxygen, and so we'll need to bring oxygen for them if they want to be on the moon. We also have oxygen filtration systems that can oxygen. So, can you please mute?
Okay.
We're not talking, but we have filtration systems, so you don't want to bring all the oxygen because we can filter it and create oxygen once we're there. If no one has any other questions, then thank you for.
What kind of experiments?
what is the future of space exploration? Like what do they have in store?
So in the future, we are planning on going to the moon, setting up more telescopes and maybe potentially going to Mars. But as of now, it's unclear if we're gonna go any further than that because the nearest star is very, very far away. and it'll take generations of people to even attempt to reach that star. And it might not even be habitable to life or not have planets that humans can live on. So right now, with our technologies, it'll be very hard to leave, for people to leave our solar system. However, we are thinking about the moon and Mars currently.
Okay, thank you.
Okay, a question, please.
Yes.
The gravity in the moon is possibly not the same with the Earth. So how do they cope with it when they reach there also?
So yeah, the gravity in the moon is a lot less. It's about a ninth of the gravity on Earth. So it basically means you're pulled down a lot less. So you can jump higher. When you walk, you step higher. And it takes getting used to, and you need to move around in different ways, but it's fine. You can get used to it, and the astronauts have. You just need it. You jump around, and everything's lighter too, so it's easier to pick things up on the moon because there's less gravity.
What's the temperature on the moon?
On the moon, there is no atmosphere, so the temperature is the same temperature of space. It's a vacuum on the moon, which is around it's 2 to 3 degrees Kelvin, which is around negative 270 degrees Celsius.
Wow.
It's just a bit above the atmosphere, which is the lowest temperature anything can be.
Why do people want to live on Mars rather than the moon?
Well, Mars does have an atmosphere, and it's more hospitable. So it actually has weather, for example. There are dust storms on Mars, and in other ways too. It's also a lot warmer because the moon is just a vacuum, it's just empty space, whereas Mars is a lot warmer and is actually around maybe like negative 40 degrees Celsius or negative 50 degrees, which is compared to like negative 270 is warmer.
How much farther is Mars than the moon?
Mars is a lot farther than the moon. The moon orbits the Earth and is very close, whereas Mars orbits the sun and can be very far away. It can be up to, I think, 200 million kilometers away.
So is it even possible to go to Mars and come back?
Yes, if you have a powerful rocket, then that is possible. However, we don't have, right now we haven't built that rocket, or we haven't planned that out yet.
But rather than going to Mars, wouldn't it make more sense to try and have like a bubble where you could live in on the moon?
Yeah, that's what we're doing right now. Right now we're focusing on the moon with the Artemis missions by NASA and the Space Launch System, and as you can see, this rocket ship. And we're actually doing test launches, and we're going to do an unmanned mission to the moon later this year, maybe, and manned missions as soon as next year, or the year after that.
Oh, okay, thank you.
Does anyone have any other questions? If you want late, you remember you can always look at any Future Astronomers courses with the Future Astronomers YouTube channel. The link is in the chat. I'll put it one more time. So feel free to check out that YouTube channel on your own time and browse through any of the other courses that we've had in the past. And with that, that's it. And if no one has any questions, feel free to leave. Our next lesson will be about, it'll be about telescopes, and we'll look into the Hubble and James Webb telescopes, but also other telescopes on Earth, like there's very big telescopes around Earth that take pictures of things like black holes and nebula. And while they aren't as clear due to the atmosphere, you can make them a lot bigger since they're on Earth, and so they're a lot easier to make bigger, which is also an advantage. So we'll learn about radio telescopes and light telescopes. And
Hello, I have a question.
yes.
Please, can you hear me?
Yeah.
Please, someone said something concerning the marks now. and how possible it to be for someone to live in the Mars. I want to know the agricultural process, can it be controlled in Mars? Is it possible, that's what I mean, for agricultural process that happen, that we are subjected on Earth, still happening in the Mars? I don't know whether that would be possible.
Yeah, it's very possible to do agriculture on Mars and to eventually plant plants on Mars once we have a base established. And we won't ever be able to do it outside because of how cold Mars is and how inhospitable. But inside space stations, it will be possible to grow food in the future. However, right now we don't have that kind of technology.
Okay. Can I ask another one?
Yes.
Okay. What about, are there things like mineral resources or special things we can get beneath the Mars?
Yeah, right now all of our Mars rovers are actually can drill into Mars and can examine the Mars rock and find different kinds of minerals and different kinds of sediments that have gathered there over the time. And that's one of the big purposes of these spaceships. As you can see in this rover, there's a drill arm coming out of the rover and drilling into Mars and gathering data. And
Okay,
we
okay,
plan
thank you so much.
to, in the future, send these samples back to Earth, where they can be examined in a more sophisticated lab. However, these spaceships are almost like mini labs where you can examine rocks and determine their composition just within it.
Okay, thank you.
With that, that's all I have for today, and I'll be ending the meeting shortly.
Thank you.
Yeah, you're welcome. Thank you for participating.
Thank you very
Thank
much.
you. Thank
Thank
you.
you so much. Thank you, we appreciate, I appreciate.
Yeah, thank you.
Thank you, sir.
Thank you so much, sir.
Okay, well, see you in a future week.